So let's discuss about device driver. So first of all, there is a distinct difference between the driver which we write in user space or microcontroller. There are user space driver also, just to tell you, and there are user space drivers also, and kernel space driver. So there are two varieties of driver. Plus, we are coming from microcontroller background, so there is we have bare metal drivers, right? We which we set directly to registers. For Linux device driver, because we are writing in environment of Linux, we have to adhere some principle. So, for example, if you write for UART driver for STM32, I have to know which register I have to set directly. So, I have to follow whatever dataset is suggesting. Similarly, when you write for kernel space driver, you have to follow the kernel API provided by the Linux kernel. So now, since we are writing a driver for kernel space, our header file will also change, where you have to put full attention. So we have Linux slash. Now we have module.h, right? Because we use a lot of kernel modules. I'll show you what are the modules. That is why we are having this header file. Then we have another header file called Linux init slash init.h. Slash init.h is like it will have init and exit function defined. Okay. Then we have another header file called eh, Linux kernel.h. Okay, because we use a lot of kernel API. Those are defined in kernel.h, like print k and others, right? Now I will write a very basic driver, static. Then have to write this flag called init underscore init. Okay, which will tell. First of all, I have to also write the return type. So for my init, it is int underscore init is macro. Okay, which will tell my kernel that it is my init code. Okay, and init code goes to a particular location in kernel space. Okay, that is called dot init. It gets called only once. Okay, because as soon as you loaded your kernel driver, you don't require after that init is just an indication your kernel driver got loaded. Okay, which we'll see whatever will write here, we'll see that in a in log. So we'll write print k here in spite of print f, right? Here we have print k, and then I'll inform that what type of log it is. So it is kernel info. Suppose I'm creating kernel information, kern info l, right? And then I'll write message is, say, suppose basic Linux device. So whatever you write, it is up to you. Okay, it is not something like very mandatory, and it indicates that your kernel module got loaded. Okay, that is what it does. Then we'll write one more thing, we'll return 0 as a success. Okay, so that is my init done. After this, I'll write again static. Then I will, since I'm closing my driver, I don't have to give a status. Again, I'll use macro called exit. Okay, so I'll write basic underscore exit. Okay, and then there is no parameter to this function again, so I'll just copy, and I'll not return anything. So I'll just write print k again, not f, because we are habitual writing f. So I'll write kern, and I'll write info, and then I'll say basic Linux device driver exit, right? Okay, unloading or exit, whatever you can write. Okay, so it should be small. I'll say init here. Okay, okay. Now one more thing. Uh, we have to tell with module init that what is my init function. So I have to tell that which module I have loaded as a init. So I'll say basic underscore init. It is my init function. Similarly, I'll have to tell that what is module which I'm treating as a exit. Okay, so I'll say basic underscore exit. Okay, so I'll just write semicolon here also. Also, whenever you write uh, any driver, you also had to give some information to your for your driver. Okay, like uh, who's author of it. So what is the license of it? Okay, so that will record in module underscore license. It is GPL because I'm not using any customized driver, which you can write GPL or Qualcomm or depends who's owning it. So module underscore license. Then I'll write module underscore author. Okay. So author means who's creating it. So I'm the creator. So I'll write my name is Prashant. Then you'll write, okay. Last is like you can also write module descriptor. Like what is this for? So I have write description. Yes. So I'll say basic uh, Linux kernel driver. Okay. So why these will be given, you'll understand. Don't worry. So this is my very basic device driver. Okay. To compile my Linux device driver, I cannot compile directly with GCC. Okay. So we need make file. Okay. So why we need make file? Because it every driver we write, it is for a specific kernel version. Okay. So if you see here, I already written my make file. I'm not sure. Okay. So I just wrote this, right? You can see this is my driver I wrote. Basic. I'm going to basic. Let me go to CD basic. Okay. Now I'll say ls. You can see that I have written basic right now, and there are again another basic is there. So what I can do is I can just write make file. Okay. Here I'll just change the name. So what is my name of the driver? My name of driver is basic underscore driver. Okay, so I'll just write basic underscore driver. Okay. Now if I write make, okay, so you'll see that my kernel driver is getting compiled. Okay, if I do ls, you can see that there is a basic driver dot o, but I'm more interested into ko will gonna be inserted in a your kernel. Okay, ko is gonna insert onto the kernel. Also you can check what is this driver is for. We can write basic underscore driver underscore driver. Okay, so I can write driver, and then I say write ko. You can read that. Okay, description which you wrote is coming here. File name, you know this where it is located. What is the license? What is the serial source version? So I can write all this information using mod info. I can check it. Okay, now we just have written init and exit. If you remember, I will write sudo ins mode basic driver dot ko, right? Now I'm inserting this into my kernel. Okay, so I have to put my, okay, then I'll check this into dmessage. Dmessage is a tool through which I can check what is happening in my system. You can see this has got loaded, right? Now I'll do reverse. I'll want to unload it, so I'll do rm mode. Okay, then if I do remessage, it is gonna say exited. Okay, so you are in it here and exited here. Okay, any question guys? So guys, now what we have done so far, that we have written init and exit before, and we have inserted that module, right? But that is just basic of the driver. Now assume you're writing a driver that should serve some purpose. Drivers are lowest layer wherein we gonna connect your hardware and your operating system, and in between we have driver which we discussed already. So whenever we create a new driver, we have to register it. Because that is new entity getting created, we have to create a new API called register underscore caddev, through which we are registering this character device driver. And this API is defined in your header file, which I will show you again. So in which first argument is 0. 0 is your major number. What is major number and minor number? Major number is your identity, like your ID card is your major number. So for example, in Hyderabad and Telangana, mostly people are having, we, or even in India, right, we have a surname. So assuming I have surname of Reddy, so Reddy is my my surname. Surname is your major number. And now in surname there is another thing called minor number. What is minor number? Minor number is an entity in which, through which I will be identified. So for example, suppose my title is Sony, Soni, and my family will be Sony family, your family will be Reddy family, or whatever family you belong to. The minor number is index in that family. Index means, like, your father is 1, 0 index, so your mother is 1 index, your sibling is 1 or 2, 3, whatever, how many you have accordingly, and then you will get another number. So you got the index for that family tree. So that is called minor number. Major numbers are given by your family. So it, like for I2C, SPI, UART, it is known. So for that, it is already pre-existing major number is given. I'll show you how you can see that. So if you got the major number correctly, it will not be less than 0. If it is less than 0, means it got failed. And then you just printed the statement that what you got, and what is your major number, and then you have to run this command mknode, where I'll come to, right, will I explain it. So like when you register your driver, so your driver got registered to kernel, but then you have to add it to some tree. So in Linux we have a lot of device tree, slash dev, slash temp, slash sys, lot of device trees are there. So I have to register your driver into slash device, because you were creating new driver, right, for one particular device. So that driver should be registered under slash dev. That is why I have to run the command called mknode slash dev. So once you register this driver, okay, opposite it unregister it, which will be happening in your exit part, okay, wherein you will have to put the major number and device name. And in it, this part, already, this is already we written, this is just for module information. Okay, now we have added some operation also. So we create file operation structure in which we are performing these operations, which is open, read, write, close. These are nothing but function pointer to these addresses. Okay, dot open, whenever I will call open API, it will be calling basic underscore open, basic underscore read, basic underscore write, basic underscore release. Okay, now you can see that I have implemented these API, and I have added few more headers. Module.h I added first time, kernel.h I added, init.h I added, but for fs and uxs I'm adding new header file. Fs.h for is for your register care device and file operation structure. Uxs is for copy to user and copy from user API. Your device name is basic underscore character. Your buffer size is 256, and this is what you are creating as a major number variable, and it is your kernel buffer. Okay, and this is your buffer size. So I will focus on read and write only, but let me tell you what will open will does. As soon as your device will be opened, your this API will be called. Okay, that device got opened. And if you remember that open API you're calling from user space also, so there is a connectivity between these two. That is why I have asked you to write that code in starting. So we have inode structure pointer and file structure pointer to as an argument. Release also the same. I'm just saying that closing my devices, my device, whatever I opened. Now assuming that you are writing basic read operation. Okay, basic read operation, what I'm trying to do, I am trying to perform read operation from the device. So your first argument is file pointer, another is user buffer, which is coming from user space, count what is the size, which your buffer size, and your offset. Okay, and here you are just checking that whether you are exceeding to, is it overflowing, so that you are checking, right, with the minimum API. I'm calling copy to user API, which will copy data from kernel space to user space. Okay, that is what this API does. Okay, and similarly we have written write also. And again, write, we are again checking whether I'm overflowing buffer size or not. If not, I'm proceeding and saying that copy from user. I will be copying from the user space to kernel space. This API is very useful when you are sending data from user space to kernel space to user space, and I'm just printing it. So in overall operation, I'm just sending data from user space to kernel space to user space. This is your structure which has to be initialized if I'm doing any operation on a file. Okay, just a minute. Now what I'll do is I will compile this code. Okay, so compiling means I have to write make only. So this make is already written, so I'm just calling this. Now if you see that I got one make file, you can see this basic character driver, and I can write mod info for this also. Mod info basic char driver. Okay, driver dot ko. Okay, you can see this is information given. Now I was telling another thing, that how what is major number. Let me show you. If you write ls minus lrta into slash dev directory, you see that you find out the family I2C number is 89. Okay, wherever you see I2C, the number is 89. 89 is nothing but your major number. Okay, now if you see other device, say I'm taking example of, just a minute, I'm taking example of disk, it is 10. Okay, root, it is 10. So for each specific device, we have given major number. You can go and check. Okay, so that is one. Now what I'll do is I'll do sudo inus mode, and I'll do basic.ko. Okay, so what is where I can see, I can go and check sudo dmessage. I can see that I created a device node. My major number is 235. Plus, what I have to do next is I have to load also. Sudo mk node. What is my command? Sudo mk node slash dev slash basic slash char. Now, this is your path where you are registering. C means character. Your major number is 235, and since you are first in a family, it will be 0. Index is 0. That is a minor number. If I do this, it is taken. Again, what I'll do is I'll just change the permission. Chmod of this location, which driver I've created, I'll change the location slash dev that basic underscore char. Okay, so I change the permission. Okay, so I have to give the permission also. So if I write, I have written 666, I got the permission also. Now if I do some operation echo hello, so I'm sending data from user space as as like a string. I'm sending slash dev slash basic slash char. You'll see that there's something got sent here. So how to check it? We have the message to check all the messages coming from user space or kernel space. So you can see that you open the device, you wrote 6 byte, hello is 6 byte, and then you have closed the device. Okay, now suppose I want to read it. Okay, I can read also. Let me read it. Cat space, so hello got printed, and it will say that it is read 6 byte. Okay, so what you have done so far, you have created a driver, inserted it, perform read and write operation, and then closed it. Okay, we'll write our API also, user space API. Let me show you the same thing which you can do is like this also. Let me show. Okay, so you have written this driver also. Here you can see that we have written f open for the same, right? So I can open directly that device, write into it, read into it through my C code also. That we will do next. I hope it is clear so far. Let's complete the task first. Okay, wait.